TS diagram, temperature entropy diagram. It is a graph drawn between temperature on y-axis and entropy on x-axis, which represents the working of a reversible heat engine, and it is called temperature entropy or TS diagram. Here we have to explain the working of Carnot cycle and efficiency by using temperature and entropy. For this, consider a Carnot cycle under PV diagram. Here this is PV diagram. In isothermal expansion AB curve, the temperature remains constant at T1 and observed heat energy from source is Q1. In adiabatic expansion BC, the temperature falls from T1 to T2 and heat energy remains constant. In isothermal compression CD curve, the temperature remains constant T2 and rejected heat energy to the sink is minus Q2. Adiabatic compression DA curve, the temperature rises from T2 to T1 and heat energy remains constant. When the heat engine is working under temperature and entropy, then we can observe TS diagram as follows. It is in the shape of rectangle A, B, C, D, E, F. We know that the entropy changes linearly in isothermal process and remains constant in adiabatic process. Using these changes, we have to explain the following 4 changes in Carnot cycle. In isothermal expansion AB, the temperature is constant and T1 and entropy of the working substance increases from S1 to S2. Heat absorbed from the source Q1 is equal to T1 into S2 minus S1. Using second law of thermodynamics, W1 is equal to Q1 is equal to AU into AB. W1 is equal to Q1 is equal to area of ABF. In adiabatic expansion, there is no change in entropy, but temperatures falls from T1 to T2. In isothermal compression, CD constant temperature and T2 and entropy decreases from S2 to S1. Then Q2 heat energy is rejected to the sink. Minus Q2 is equal to T2 into S2 minus S1 is equal to dE into CD. Minus Q2 is equal to area of CDEF. This is equation 2. Finally, in adiabatic compression DA curve, the entropy remains constant but temperature rises from T2 to T1. So by combination of these 4 changes, TS diagram indicates rectangular shape ABCD. Efficiency can be defined as the ratio of amount of work done to amount of heat energy absorbed by the heat engine. From equation 1 and 2, eta is equal to W by Q1, that is equal to Q1 minus Q2 by Q1. Eta is equal to 1 minus Q2 by Q1. Then eta is equal to area of ABCD by area of ABEF, that is equal to AB into AD by AB into AE. Then eta is equal to T1 minus T2 by T1, that is equal to 1 minus T2 by T1. This is the expression for Carnot reversible heat engine using TS diagram. The efficiency can be depends only on temperature T1 and T2, but it does not depend on working substance.